All right, so here's the first thing that we're going to go over on our complex numbers mashup day. Okay? Complex numbers. I meant to say on our quadratic mashup day. The first thing we're going over is complex numbers. Okay? So just as a sort of review, what does I equal? Square root of -1. Good. And what does I squared equal? -1, right? Because if I square both sides of this, I get that, right? Okay. So the first thing you have to be able to do is what? Do you remember what are the three things that we have to be able to do with complex numbers? 3 operations. So I don't mean like appendix or something like that. That's correct. Add, subtract, and multiply. Okay. So let's see if we can add 2 plus 3i plus 4 plus 5i. When we are adding complex numbers, what parts do we add? So we add the real parts, right? Does anyone know what 2 plus 4 is? Excellent. Because that's the real part, right? And then what do? Add the imaginary parts. 3i and 5i. 8. Yeah, not 7, but 8. Yeah, 8i. Okay? All right. Do you have any questions about adding? Do you need any more examples of adding? You're good? Okay, just making sure. Okay. Now guess what's next? Subtracting 4 plus 5i minus 3 plus 8i. Now what do you want to do here? You want to subtract, okay? If you want to subtract, what do we subtract? Real parts. What is 4 minus 3? 1. What is 5i minus 8i? 5i minus 8i, -3i. Okay? Now, I know it seems maybe a little over the top, but I do want to do one more subtraction problem to remind you that there's another way we can do this. Is that okay? Let's do 7 plus 3i minus 6 minus 4i. Oh, my favorite one. Do you remember that we could do what with this? Oh yeah, we could distribute the -1, couldn't we? So this is really plus, and this is really minus, and really plus. Do you remember we could do that? Okay, so now it's just an addition problem, which you apparently love. Well, for good reason. You're good at them, right? 7 and -6. 1. And then 3i and 4i. 7i. You good? Any questions on adding or subtracting? Okay. Then let's go to... Okay. So first of all, let's multiply something like this. 5 times 2 plus 4i. How do we do that? We distribute. Okay. So what is 5 times 2? What is 5 times 4i? 20i. Done. That's it, right? You okay with that? What about this one? 6i times 3 minus 5i. 6i times 3 minus 5i. What do we do here? Still distribute, right? What is 6i times 3? 18i. What is 6i times 5i? Or -5i, right? -30i squared. This time are we done? Why are we not done? Because I squared equals what? -1. This is -1, so that becomes positive 30, right? So what's my answer? I mean, I could write 18i plus 30, but I want my real part first, don't I? 30 plus 18i. Now, is it wrong to write 18i plus 30? No, but all of your mathematician friends will make fun of you for writing the imaginary part first. All one of us. Good? 2 minus 5i times 3 plus 6i. What do I do? Distribute. What's 2 times 3? 6. What's 2 times 6i? 12i. Okay, what is negative 5i times 3? Good, negative 15i. And negative 5i times 6i? Negative 30i squared, right? Okay, God bless you. So am I finished? Oh no, that would be ridiculous, right? So where do you want to go first? So I can do two things at one time? I can combine these and mess with the I squared? Oh, for sure, right? I squared is what? -1, so that's really positive 30. So I have a positive 30 and a, which is 36. And then I have these like terms. Perfect. How do you feel about multiplication? Do you need me to do any more examples of multiplication? You sound very confident. Okay, good. Well, we'll leave it there then. No, that's fine. Okay. Here's our next mashup topic. Quadratic inequalities. Okay, quadratic inequalities. There's two types of these that you're going to have to know how to do. Okay, we'll start with this type. X squared minus 7x plus 10 is greater than or equal to 0. How many variables are there here? So one variable, and it is x. Okay, so I'm going to solve for x, and then I'm going to graph it on a number line, because a number line only has one variable, right? It's only the x variable. Got it? Even if it's an n or an m or a p or whatever, it's still going to be a number line, one variable. Got it? How do I go about solving this? I could factor, absolutely. What multiplies to be 10 and adds to be -7? So, yep, -5 and -2, right? What do I do with each one of those factors? Do you remember what that's called? What tells us to do that? The zero product property. Remember that? X minus 5 equals 0. X minus 2 equals 0. So what does x equal? 5 and 2, absolutely. Okay? Now here's what I do. I go to my number line. There's the 3 numbers that I want on my number line. Okay? Whatever 2 answers that I got, and then one other one. What other one is the easiest to choose? 0. 0, 2, 5. At this point, I don't really care that they're spaced out evenly, but wherever the 0 is, I need to make sure it's in the right place. I don't want to put a 0 right here, right? Because 0 is not between 2 and 5. Does that make sense? Okay? So remember the rule about this. Where is the answer? It's either in between 2 and 5 or outside of 2 and 5. Do you remember that? It's either in between or outside. How do we decide whether it's in between or whether it's outside? Choose a point, right? Choose a point. 0 minus 0 plus 10. 10 is greater than or equal to 0. Is that a true statement? Is 10 greater than or equal to 0? Yes, it is, right? So wherever the 0 is, that is part of the solution. So for sure, part of the solution is right there. Well, in this particular problem, if I know part of the solution right there, is that the only part of the solution? No, where's the other part? On the outside of 5. Because I know it has to be either between them or outside of them. So if I know one is outside, then I know the other part is outside as well. Does that make sense? Now, what goes on the 2 and the 5? Look back at the original sign. And remember that is a colored in circle, a solid circle. And that's our answer. Okay? Now, we could rewrite it so that it looks prettier and makes more sense. Because right now, it actually only says x equals 5 and x equals 2, and that's not actually the answer, right? So not only could we rewrite it, but we probably should. Okay? And by probably should, I'm saying do it. Okay? So, it's everything, what? To the left of 2, so x is less than or equal to 2, or x is what? Greater than or equal to 5. Perfect. Why did I put this or in here? Yeah, definitely it's an or statement, right? It's either one side or the other. There's not a number that's less than 2 and greater than 5, is it? Is there? Okay. And now we're finished. We good? Can I do another example for you? X squared minus x minus 12 is less than 0. So what do you want to do first? Factor? Okay. What multiplies to be negative 12 and adds to be negative 1? Yeah. What do I do with each one of these factors? Zero product property says set them equal to 0, right? So what does x equal? And 4 and negative 3. So what numbers am I going to put on my number line? So negative 3 and 0 and 4. Perfect. What if 0 is one of my numbers? What do I do then? Literally choose another number. It doesn't matter what it is. It just can't be one of the two that's already part of our solutions, right? 0 we like to choose because it's the easiest. So if we can't choose 0, what might we choose? 1 or 2, something like that, right? Okay. Now what do we do? Take the 0, plug it in, right? 0 squared is 0, minus 0 is 0. So negative 12 is less than 0. That's true, right? So it's true where the 0 is. So that part is for sure shaded. Are there any other parts that are shaded? No. How do you know that for positive? Yeah, it's either inside or outsides. If it's inside, that's it. That's what you got, right? What goes on negative 3 and what goes on 4? Absolutely. Open circle. And why is it an open circle? Because it's not equal to. Remember, let's write ourselves a little note. Less than or greater than is open. Less than or equal, greater than or equal is closed or filled in. You okay with that? Any questions on graphing quadratic inequalities in one variable? Okay. Okay, so what's different? There's a y. What's different in how we solve it? Yeah, nothing, right? Nothing is different in how we solve it at the beginning. Is that fair? Okay, so what do I do first? Factor, that would be a great choice. What do we get? Minus 8 and positive 2. What do I get from, what do I do with both of those? X minus 8 equals 0. Very good. X plus 2 equals 0. So x equals what? And? Perfect. Do you guys notice that we started skipping a step in here? Did you even notice that? I didn't go plus 4, plus 4. Oh, x is 4. I didn't go minus 3, minus 3. Oh, x is negative 3. I didn't go plus 8. Oh, it's 8. Minus 2, minus 2. Oh, x is negative 2. You guys are getting better at that. Excellent. Now, here's where things change, right? What are these two numbers? X-intercepts. That's exactly right. Okay? So that means that is where my parabola crosses the x-axis, right? Now, when we're doing quadratic inequalities, we got to be real careful where our parabola goes, right? I can't just go whoosh. I really need to know where the vertex is, don't I? How do I find the vertex in standard form? Oh, look what I happen to have. Negative b over 2a. Remember that? Negative b over 2a is 3. That means the x-coordinate on my vertex, I'm going to write this in blue, is 3. How do I find the y-coordinate on my vertex? What does that mess mean right there? We plug it into the equation, remember? So plug 3 into the equation. What's 3 squared? 9. What's 6 times 3? 18. What's 9 minus 18? Negative 9. What's negative 9 minus 16? Negative 25. Okay. Now, we have a problem, don't we? On most of the graph paper I give you, I can go over 3, right? Can I go down 25? No, I can't even do this on my paper right here, can I? So what's it going to actually look like when I graph it? Well, first of all, I have to make sure it is dotted. But it's going to look more like this, right? It's not going to look like a whole parabola because I can't find the vertex. Well, I can find it, I just can't fit it on my graph, right? What's left to do to finish this problem? Yeah, I have to shade it, right? Now, what are my choices for shading? Correct. I can either shade inside or I can shade outside. Okay? How do I decide whether I shade inside or outside? Yeah, look for clues. Choose a point. If I choose 0, 0, I plug 0, 0 into my original equation. I get 0 is greater than 0 squared minus 6 times 0 minus 16. Does anybody know what 0 squared is? That was a joke for the record. Okay, so 0 minus 16. So 0 is greater than negative 16. That is a true statement. So where do I shade? Yeah, because that's where my 0, 0 is, right? Or that's where the point that I chose is. You feeling okay with this? Yes? Okay. Do I need to do any more examples of quadratic inequalities for you? Either one variable or two variables. Okay. Again, you sound very confident. That makes me happy. Okay. But for the record, even if you weren't sounding very confident, I would be proud of you and we would work together to get more examples. Fair? Okay. Writing the equations of parabolas if I give you 3 points. Do you remember how to do this? So let's write down the 3 points first, and we'll go from there. It is, But if it's okay, do you mind if I show you a second way as well? You okay with that? But let's do with the matrix first, because that's how we talked about it first. So remember, we got to put in our REF, and then what goes on our matrix? Let's remember this real quick. AX squared plus BX plus C equals what? Y, absolutely. Okay, so what does it want me to do with the X first? What is 5 squared? What does it want me to do with the X next? Just write it down, right? What do I put here? Always a 1, and then what's my Y? 7. So my first row of my matrix is done. Where do I get my second row of my matrix? The second point. Okay, what do I do with the X? Square it. What's negative 2 times negative 2? 4. What do I do with the X next? Write it down. What comes next? 1. And what comes last? The Y, which is 12. So that's the second row. The second row came from the second point. Guess where the third row is going to come from? Yes, third point. What do I do with the X? I square it. What do I do with the X now? Write it down. What do I do here? 1. And what do I do here? 1. Okay. All right, let's put this into our calculadora. New document. No, I don't want to save the old one. I want a calculator. I want it to menu, matrix, reduced row echelon form. I want to do menu, matrix, create a matrix. This matrix is a 3 by 4 matrix. And then I just go put the numbers in. Okay. Oh, sorry. I'm going to zoom in so you can see mine. Unless it's going to be a jerk. There we go. Okay. 25, 5, 5, 1, 7, 4, negative 2, 1, 12, 9, 3, 1, 1. Okay, you got yours in there like this? So I'll tell you this right now. When people get an answer like that, what's their first reaction? I did something wrong, right? This is ugly. I did something wrong. Guess what? It's the right answer. So here's what I got for my matrix. 1, 0, 0, 26 over 35. 0, 1, 0, negative 103 over 35. And then 0, 0, 1, 22 over 7. What's the equation of the quadratic that passes through these points? I have all the information I need. I need to write the equation. Y equals what? What's this? What's this? And what's this? C. And remember from back up here, it's ax squared plus bx plus c. So now we're just filling in blanks, right? 26 over 35 x squared, because it's ax squared, plus bx, so minus 103 over 35x. I could put plus a negative if I want. Either one's okay. And then plus c, which is 22 over 7. You okay with that? So here's the deal. This is one way to do this problem. Can I show you another way? Okay. So, real quick, let me do something real quick. Oh, seriously. Okay, so what I want you to do is add a page. Do you know how to add a page? Control Doc. Control here, Doc here. I want to add a page or just completely start over, right? Either one is fine, but I'm adding a page that's a lists and spreadsheet. Shockingly, it looks like a spreadsheet. Okay? Now here's what we're going to do. In this first column, what's wrong? You good? Let me see real quick. Oh, because you're in a scratch pad. You have to be in a document. And then list and spreadsheet. Okay? So what we're going to put in this column are all the X's. So let's go up here to the very top where the A is in the cell, and let's call it X. Well, what are my X's for this problem? 5, -2, and 3. Yes? 5, -2, and 3, you okay with that? What should I put in now? Yeah, wouldn't it make sense to put the Y's in now? Okay, if I put the Y's in now, I want to come over here and call this column Y. I'm going to zoom in just a little bit more so you can see what I'm doing. So what are my Y's for this problem? Does it matter what order I put them in? Oh, absolutely, right? If X is 5, what's my Y? 7, right? I for sure have to keep the right Y values with the right X values, don't I? Okay, so 12 and 1. So you got all 3 of those in there? Now, what I want you to do is add a page again. So Control Doc to add a page. But the page that I want is the data and statistics page. Okay? The reason I add a page instead of starting over is when I add a page, it's actually going to pull in the data that I just used on my list and spreadsheet page. Now, if I was a betting woman, and I am not, I would bet you money that our graph looks different right now, like than each other. And I would bet that all of our graphs look different from each other. That's okay, because we're about to make them look the same. You ready? Use your mouse little keypad here and come down here at the bottom where it says click to add a variable. Which axis is this? Yeah, it's the x-axis, isn't it? And then you get to watch the points move on the page. And then come over here to the left-hand side where it says click to add a variable. What axis is that? A y. And then you get to watch it move again. Now, here's where the magic is. It's not really magic, it's just a calculator. Okay? Let's press menu and analyze and regression. In Algebra 1, you probably did linear regressions or lines of best fit. It's a line that gets as close as possible to all the points that we entered in. Well, this is a quadratic and we only entered 3 points, so guess how many points it's going to touch? Yeah, all of them. Okay? So regression, and we're going to say show quadratic. We're going to choose number 4 for show quadratic. Boom. There's the equation right there. Okay, now here's the thing. Does that look exactly like the equation that we got as our answer? No, but here's what I want you to think about. What this says is 0.74 minus 2.94 plus 3.14. Now I'm going to go back over here because this is what I did a second ago. I actually put these fractions in so you can see what their decimal equivalent was, so that you can see that what we just got is the same as what we got here. Does that make sense? So does it matter which way you do it? No, it does not. Okay, you can do it either way. Either way, you're using the calculator, aren't you? Okay. Do you have any questions about finding the equation of a parabola given 3 points? Now, what if the problem showed up looking different? What if I said this? What if I gave you the data in a table? Guys, what did I just give you? I just gave you exactly the same thing, didn't I? It's just presented in a different way. Can I solve it the same way, either with a matrix or with the data and statistics page and list and spreadsheet page? Yeah, absolutely. Whether I give it to you as points or whether I give it to you as data points in a table, it's the same thing. You okay with that? Okay. Tell me on a scale from 1 to 10, 10 being I understand this 100% and could teach it tomorrow, and 1 being I just woke up and don't know what's going on. Where are we with 3 points? How confident are you? 9, 8, 6? Those are all good. Okay. How are you feeling about quadratic inequalities? 7? 6 and 7? Okay. So that's maybe something we need to work on a little bit more. And then what about complex numbers? Ooh, excellent. I like hearing 10s. Okay. Are you ready? We good?